Hi guys, welcome to 5mantra.com. This is Kalyan, the faculty of aptitude. So guys, already we have done an exercise based on this triangle and circular combination like this. This kind of combinations already we have done one exercise with 4 or 5 problems. Now without options, just for solving we do solve 3 problems on this board. Okay, and one by one, one after one we solve. Before solving this, once again I am writing the shortcut for this. Okay, whenever we have given circles like this in the triangles, in an equilateral triangle, if 3 or 6 or 10 or any more circles are given, then how to find out the shaded region. Based on that, already we had a discussion, and before that we already had given a shortcut about finding the side when radius of each circle is given r. Here in this case or in this case or in this case or up to n rows case. Okay, what is the shortcut to find out the side of the triangle? What is the shortcut to find out the side of the triangle when the radius of each circle is r in each case? What is that? We said already, that is 2 root 3 r plus 2 into n minus 1 into r. And what are the details? Here n is what? Number of rows of circle, and r is radius of each circle. R is radius of each circle and n is number of rows of circle. Once again showing you that what is n? See, how many rows of circles are here? 2. So n equal to how much? 2. Here how many rows are there? 3. So what is n equal to? 3. And how many rows are here? 4. So what is n equal to? The n value would be 4. Like such we are taking this formula, and this shortcut is very important for finding the side of the equilateral triangle where radius of each circle is given. So this is the first thing we have to remember before going to start this problem. Okay, now what is asked to find? Straight away we are going to enter into the problem. Now we'll solve one by one. First we start with this first problem, and later on we solve the remaining 2 also. Okay, now let us start the first. Okay, see you guys. So what is that now? What is this diagram? In this diagram, 3 circles of equal radii are given. 3 circles of equal radii are given, and each radius of the circle would be 4 centimeters. Then you need to find out the shaded region. Shaded region in the sense blue color region. Once again reminding you, what is meant by shaded region? The area unoccupied by circle inside the triangle, or the area left inside the circle, remaining area other than circles, that we need to find. So anyways, what is the core idea for doing this problem? We need to subtract areas of the 3 circles, means sum of the areas of the 3 circles. We need to subtract sum of the areas of these 3 circles from entire triangle. That's the first thing you need to understand. Once again repeating, what we have to do here, we have to subtract the sum of the areas of 3 circles from area of the triangle. For that we need to know what kind of triangle is this. Already we know from our core concept. What is that? Here this triangle is equilateral triangle, and we know how to find out the area of equilateral triangle. Equilateral triangle area would be root 3 by 4 a square, where a is a side. A is what? Side. And here if you want to find out the circle, then what if radius is given, then pi r square is your circle area. But here the magical thing is we haven't given the side of the triangle, only radius is given. that time we have to use the shortcut which we said before to find out the side. First let us find out the side. That is our first challenge. After finding the side, we have to find out the area of triangle, and then after already my radius is given, then we have to find out the circle area also. Okay, for our convenience I am telling you, don't use this 4 centimeters in the beginning. Do the entire process, and at the end of the step you put the R value as 4. Otherwise it will get lot of confusion. Once again repeating, don't use this 4 centimeters at the beginning of the problem. Let us analyze all the problem. At the end of the problem we substitute 4 in place of R. Okay, that's our way to do this problem. Let us do start. Okay, now here what we have to do. Here first of all we need, our target is to find out side of the triangle, because radius is given. So let us suppose radius of, for our convenience I am not taking R as 4. Now at present I am taking each radius as R. If each radius is R, then what the shortcut we said, 2 root 3 R plus 2 into n minus 1 into R is a side of the triangle. Is it right or not? So what is n? Number of rows of circle. N is what? Number of rows of circle. So what is here n? N equal to 2 or not? And what is the radius? R. Of course it's a 4, value is 4. We substitute that at the end of the problem. Now let us go through this. I'll do this problem first, and then after we'll do remaining ones. Okay, now first this, we need to find out the side. What is side? Tell me, what is side in the sense 2 root 3R plus n equal to, we need to place 2 here. 2 minus 1 would be 1. 1 into 2, 2R. So that means 2 root 3R plus 2R. That is your side of the triangle. Means each side of the triangle. So this one we got. Okay, we got side. And radius of each circle is given as obviously R, because using that only we could find this much. Okay, this is R. Your first step is over. After finding this, okay, after finding this, what we have to do? We need to subtract the area of the 3 circles, means sum of the areas of 3 circles from area of the triangle. So here shaded region, shade area equal to area of triangle. Area of triangle would be how much? Root 3 by 4 into a square. A in the sense side. Okay, that is root 3 by 4 a square. See guys, I want to take common 2R from the terms so that it can be easier for us to do the calculation. Okay, so that would be how much here? 2R is taken common. Here root 3 plus 1 will be left inside. Okay, now this is a or not? Is this a or not? Root 3 by 4 a square means this whole square. Got it? Because your side is 2R into root 3 plus 1, you have substituted in place of a, and you can find out the area of what? Equilateral triangle. Now from that, to find out the shade area from this equilateral triangle, we need to subtract 3 circles areas. Each circle's radius is R. Each circle area would be pi R square. How many such circles are existing over there? 3. So total 3 circles area would be 3 pi R square or not? So minus 3 pi capital R square. Once again repeating, this is shade area, which shade area will be equal to area of the triangle, which is root 3 by 4 into 2R into root 3 plus 1 whole square, minus 3 circles area, each circle area pi R square minus 3 pi R square. This is minus. Okay, this is minus. Okay, now let us do the simplification. Okay, let us do the simplification. What we have to do here, just see, root 3 by 4. This is 4r square or not? Okay, 4r square means 4r square into root 3 plus 1 whole square or not? Once again, we can't write everything on the board. You need to minimum, these things are algebraic formulas. Right from your 6th or 7th standard you are learning in your schooling days. So better you can do this on your mind only. How can we do this? Root 3 plus 1 whole square. Root 3 plus 1 whole square can be written as root 3 whole square, that is 3. 1 whole square, that is 1, means a square plus b square. Next 2ab. What is that 2ab? 2 into root 3 plus 1. So here root 3 whole square 3, 1 square 1, that would be 4. 2 into root 3 into 1, 2 root 3. So that means here in total what is that? 4 plus 2 root 3, isn't it? Minus 3 pi r square. This is our next step. Now can we do the cancellation for 4 or not? We can do the cancellation and then after do multiply all this. What do we get here? 4 into root 3, that is 4 root 3. Here r square is there or not? R square. And here root 3 into root 3 r square into 2 root 3. Root 3 r square into 2 root 3. First root 3 into 2 root 3. 2 root 3 into root 3 would be 3, 6. Okay. 6 r square. Right? This is how much? 6 r square minus 3 pi r square. Now finally here we got this last step. At this step better we do the substitution of the value of radius, which is given as 4 centimeters. Why I said you to substitute this value at the end? Because problem looks very clumsy from the beginning onwards. After doing the entire analysis, now you can substitute here and you can get easy answer. Right? Now what is 4? What is radius? 4. So substitute here. 4 into root 3 4 square plus 6 into 4 square minus 3 pi into 4 square. Now just doing simplification we get the answer. What is that? 4 square into 4 means 4 4s are 16, 16 4s are 64. That is 64 root 3 plus 4 4s are 16, 16 6 ja 96 or not, plus 96 minus 4 square 16, 16 into 3 48, isn't it? So 48 pi. So what is your final answer? Okay, here 64 root 3 plus 96 minus 48 pi. So what is your final answer? 64 root 3 minus 96 plus 96 minus 48 pi. So in our next problem, what are the things to be prepared? Again here also this is a common question for all the 3 diagrams. We need to find out the area of shaded region. Shaded region means area inside the triangle. Okay, remaining area inside the triangle other than circles. That means this blue color part, this blue color shaded part we need to find out. Now let us see the second problem. How many circles are drawn inside the triangle? 6 circles. What kind of triangle is this? Equilateral triangle. And what the measurement is given? Is radius given or side of the triangle is given? Side of the triangle is given, and we need to find out the radius here. That is the twist, because every time measurements will never be given in favor to us. Okay, we have to make them favorable to us, and means we need to work out on that. Okay, anyhow, so what is given to us here? We have given triangle measurement, that is 4 centimeters side. Side is given as 4 centimeters, and we need to find out shaded region. So in order to find out shaded region, what we have to do, we have to subtract the area of the 6 circles, area of the 6 circles from area of triangle. So for finding the area of triangle, side is needed. We had it 4 centimeters. For finding each, all the circles are equal circles. So for finding area of the circle, we need radius. For finding the radius, we have to again use the shortcut of this. Okay. So what is the link between this radius to this side? Okay. When radius is capital R, then your side would be 2 root 3 r plus 2 into n minus 1 into r. 2 root 3 r plus 2 into n minus 1 into r. Radius is unknown. We have to find it in order to find out the areas of the circles. Okay. So here we have to find out the radius, and n is what? How many number of rows are there? See, how many number of rows are there? 1, 2, 3. So n will be equal to 3 for this problem. Okay. So here n equal to 3 and side equal to 4 centimeters. Anyways, when n equal to 3 and radius is capital R, then what is side of equilateral triangle? As we said, 2 root 3r, 2 root 3r plus 2 into n minus 1 into r. What is that? 2 into n minus 1. N minus 1 would be how much? 3 minus 1 into r. So what is that? 2 root 3, okay, 2 root 3 r plus 4 r. 2 root 3 r plus 4 r. Here problem should be solved in 2 stages. First we need to find out the radius, and then after we need to find out the circles and as well as triangle area, and we need to do the subtraction. So first task we have to finish. Here what is the side of the triangle we got? 2 root 3r plus 4r. But it is given in the triangle that what is the length of the side? 4 centimeters or not? So can we equate this value to the side or not? We obtained according to the procedure 2 root 3r plus 4r is a side, but its value is given as 4, then it will be equal to 4 or not. So here 2 root 3r plus 4r equal to 4, because here r is, we need to find out r. So we take common 2r. What is the rest value? 2r into root 3 plus 2 equal to what? 4. This 2 will go down. So in denominator part. So definitely we can cancel from here only. 2 2s are. So r equal to 2 by root 3 plus 2. 2 by root 3 plus 2. But in denominator part we shouldn't keep it as a complicated figure. So let us do rationalization. As the rationalization factor of the root 3 plus 2 is root 3 minus 2 from surds, we can divide and multiply with that. So what we get? Root 3 minus 2 by root 3. Okay, let us see second problem. In second problem we have 6 circles of equal radius. Let us suppose each circle radius is some capital R. Okay, then as we know that when radius of each circle is capital R, then side of equilateral triangle would be 2 root 3r plus 2 into n minus 1 into r, where n is number of rows. Okay, here we have given, what is given? Here radius is given or side? Side is given. So that means here we what is our target? We have to subtract sum of the areas of 6 circles from the area of triangle. So here we have to find out the area of circle as well as area of the triangle. It is possible to find out the area of triangle because side is given, but area of the circle we can find only when radius is known. So here our first target is to find out radius. That means here first problem can be completed in 2 stages. First stage we need to find out radius, and then after we need to find out the area of circles and area of triangles subtracting from one another. Okay, now let us do this. Now how many, so here what is the side of each, if each circle radius would be capital R, then what is the side of this side of the triangle? To find 2 root 3 R plus 2 into n minus 1 into R. N is representing number of rows of the circles, or like this. How many number of rows are there? N equal to 3. So let us substitute and we get this. Okay, so here side of the square is equal to how much? 2 root 3 R plus 2 into 3 minus 1 into R. N equal to 3 I put. Okay, now here 2 root 3 R, okay, plus 3 minus 1 would be 2, 2 into 2 will be 4, 4R. So this would be 4R. Now we can take common 2 from this. What is the result then? 2 into R, then here root 3 is left and here 2 is left inside bracket. So finally what is the side? 2R into root 3 plus 2. Now, but we have given the value of side as 4 centimeters. So can we make them equal or not? So here 2R root 3 plus 2, okay, 2R into root 3 plus 2 would be equal to 4. Now if you transpose this all values to another side, then 2 will come to denominator part. So from here only we can do the cancellation. By the way, we get radius equal to 2 by root 3 plus 2. As we know that in denominator part, if we have surds, the calculation will be more difficult. In order to make it simplified, what we have to do, just simply we have to do the rationalization of denominator. As you know from the basics of the surds, rationalizing factor of root 3 plus 2 would be root 3 minus 2. Multiply and divide with that and you will get here, see, root 3 minus 2 and this is root 3 minus 2. So what is the value then? 2 into root 3 minus 2, 2 into root 3 minus 2 by, okay, here root 3 plus 2 into root 3 minus 2. It's an algebraical identity. Okay, it's an identity of algebra. What is that? A plus b into a minus b, which can be further written as a square minus b square. Okay, so a square minus b square means root 3 square minus 2 square. Root 3 square would be 3, 2 square would be 4, 3 minus 4 would be minus 1. In order to reset this, if you multiply and divide with minus 1 on both sides, what happens? 2 into 2 minus root 3 will happen. Signs are changed. So finally, what is your radius? 2 into 2 minus root 3 or not? Okay, radius is 2 into 2 minus root 3. When radius is found, then what can we find finally? Let us see. So you find the radius of each circle in the second case is equal to 2 into 2 minus root 3. Now what we have to do? We have to simply subtract the areas of 9 circles from the triangle. So here shade area is equal to area of, I'll partition like this. So here area of the shade is equal to area of triangle minus 9 circles areas. So area of the triangle would be root 3 by 4, because it's an equilateral triangle. Area of the equilateral triangle is root 3 by 4 a square. So here root 3 by 4 into, what is the side given? 4 or not? So that would be 4 square minus, here how many circles are given? Total 6 circles or not? So 6 circles area. So 6 circles means 6 into pi r square, where pi is pi into r is given as, r we find as this much. So 2 into 2 minus root 3 whole square. This is what. Now 4 square can be cut down. So finally what we are getting? 4 root 3 minus 6 into, this is 2 square 4, 4 into 6 24 pi into 2 minus root 3 whole square. Further, if you want to simplify in the form of algebraic identity a minus b whole square, what is a minus b whole square? A square plus b square minus 2ab. Let us write that. Here 4 root 3, here 4 root 3 minus 24 pi into a square plus b square minus 2ab. A square is 4, root 3 square is 3, 4 plus 3 is 7, minus 2ab, minus 2 into a is 2 and b is root 3, 2 into root 3, that would be 4 root 3. Now what it is on multiplying? So 4 root 3 minus 24 into 7. 24 7s how much? 27s are 140. Okay, and 4 7s are 28. 168 or not? 168 pi minus 24 into 4. Minus of minus plus, minus into minus. Okay, 24 into 4, 96. Okay, root 3 pi. So what would be your answer? Okay, 4 root 3 minus 168 pi plus 96 root 3 pi. So this would be your answer for this question. So once again, small repetition because some of the students may not understand. So we find r by using this shortcut. Okay, radius value is 2 into 2 minus root 3. After that, what we have to do? We have to subtract the 6 circle areas from area of the equilateral triangle. Area of the equilateral triangle is root 3 by 4 a square. A value is 4, we can be substituted, and each circle area is pi r square. R is 2 into 2 minus root 3, and such as 6 circles should be subtracted. I made it 6 times, and after doing further simplification, we finally got what is the answer for this question. 4 root 3 minus 168 pi plus 96 root 3 pi is your answer for this question. Remember, carefully you need to apply for this kind of problems, this kind of patterns. You will get a long answers only. And one more thing you need to take care of. If so, you could find here radius. Okay, you could find here radius very fastly. Even this is involving some 2 to 3 steps. Okay, after finding the radius. If suppose you don't have a technique to find out radius like this, then it will take some more process in additional to that or not. So here this side of the triangle 2 root 3 r plus 2 into n minus 1 r is helping us, okay, to avoid the process to find out the radius. At least we could find the radius here. Then further simplification anyways we have to do. Sometimes we need to do the process also like this. So anyways, which is unavoidable we have to do, and up to which value we can apply the shortcut, we can apply. Okay, only we could apply this shortcut and we could find the radius of the each circle, and then after we have subtracted, okay, area of the triangle minus 6 areas of the circle, and final answer was this. I hope you guys would have enjoyed this video and you might have understood that how we are applying the shortcuts while doing the problems. See guys, we provide you the exercises like this only so that you can understand that how to use the shortcut and where to use and where not to use. So if you like this video, don't forget to subscribe our channel so that we can come up with a new and fresh content videos on quantitative aptitude and geometry mensuration for CGL and CHSL and banking. Thank you.